It's a great pleasure to be here. I get invited to scientific conferences a lot. I seldom get invited to seminaries to talk, and I'm excited that you came out here. You maybe didn't know that a physicist was going to talk today, because I'm sure you didn't get up this morning and go, I just don't hear enough physicists talk, and so I need to go hear another one. The universe is a pretty wild wilderness, I will say that, so that's a good thing. And it's particularly good to be in North Carolina in March, in ACC country, because in the Big 12 we play football, but I don't think we play basketball. So anyway, as it was said in the introduction, I'm a professor at the University of Oklahoma. I've been there over 20 years. I do research at a laboratory called CERN Laboratory near Geneva, Switzerland, and I'm a Christian as well. And I have the opportunity to speak at universities and churches and seminaries occasionally on the intersection between science and Christianity, and that's what I will be doing mostly today. But I got to start by telling you a little bit about my research. This is what the quiz will be on at the end, so take good notes on this. We know that the universe is made of atoms, and inside every atom is a nucleus. The nucleus is really small compared to the atom. If the atom was the size of this room, the nucleus would be about the size of a little pinpoint in the middle. And then the nucleus is made of neutrons and protons. Neutrons and protons are made of quarks, and I've spent most of my career studying quarks. How do the neutron and proton, what's their makeup? How are they put together? So how do we know how a neutron and proton is put together? Well, suppose you wanted to know how your car was put together and you didn't have any tools to take your car apart. What would you do? Well, if you're a particle physicist, here's what you do. You get the car going really, really fast, and you smash it against another car going really, really fast, and you see what comes out. I tell my students, do this with your parents' car, don't do it with your car. So near Geneva, Switzerland is a tunnel that's 17 miles around. It goes under farms and villages and near the Geneva airport. And inside that tunnel, there are superconducting magnets that accelerate and bend protons moving nearly the speed of light. If you look in this picture, you see two pipes that are covered. Those pipes would carry protons in opposite directions, and then every once in a while around this 17-mile ring, as shown in this drawing, we bring those protons together, we smash them together, we see what comes out, and we build big detectors to see the debris from the collision. The detector I work at is called ATLAS. It stands for a toroidal LHC apparatus. Look that up on Google when I get boring, so you know what it means. But you can see that this is a gigantic detector. If you look in the very bottom of the picture, or kind of halfway up, you see little individual people. Those are people, little figures. You see those? So this detector is about 10 stories high. Protons come in opposite directions. They smash in the middle of the detector, and the computer takes pictures that look something like this. And I spent 7 years as a graduate student and 7 years as a postdoc, so I could understand what my kids call spirograph drawings. And so that's the goal. This was actually one of the two detectors that in 2012 discovered the Higgs boson, sometimes called the God particle. Not by physicists, we don't call anything God, but nature itself maybe. But anyway, I was one of the 7,000 people who helped discover this particle. And two physicists won a Nobel Prize for predicting this in 1964. So that's what I do in my professional life. People come to me and say, well, Christian scientist, isn't that an oxymoron? Is it possible to be a Christian and a scientist? My non-Christian friends think that can't happen because the Bible is a book written by men. It's full of myths, and doesn't science contradict everything in the Bible, particularly the story of creation? My Christian friends say the same thing. They say science is dominated by non-theistic assumptions. How can you trust what it says? And doesn't the story of creation disagree with what science has found? But in reality, we know that that can't be the case, this apparent contradiction. Why can't it be the case? Because the same author who created the universe wrote the book of Scripture. And the same author should speak with a single voice when he talks in the universe or when he talks in his word. And he's a God of truth. He cannot lie. So the truth he gives us in Scripture should align with the truth he gives in nature. And that's what I found. I have a friend who's an artist. He's actually a very good artist. One of his paintings hangs in the state capitol in Oklahoma. It is Oklahoma State Capitol, not North Carolina, but nevertheless, he says that when you look at a piece of art, you see the soul of the artist. As a scientist, I get to look at God's piece of art, and I get to see his soul. And I want to share today some of the things I've learned, some of the modern scientific evidence that actually points to God. Science doesn't move us away from God, but the better we understand nature, the more we look at it in detail, the more science actually draws us towards God. I often give this talk at secular universities. I just gave it at North Carolina State last night, and we talked about there the scientific evidence for God. How does God show himself in nature? And I want to talk about three things: the origin of the universe, the design in the universe, and something called the rare earth hypothesis. So we'll start with the origin of the universe. If we lived 100 years ago, scientists didn't know that the universe even had an origin, but now every scientist believes that the universe had a beginning, something that is called the Big Bang. And that the Big Bang is not, it's really a misnomer. There's nothing there to bang. In fact, the Big Bang, the term was coined by a scientist named Fred Hoyle, who didn't believe the universe had a beginning and thought if he came up with an audacious name for this beginning, then no scientist would accept it. So he coined what he thought was a silly term, the Big Bang, and it stuck. But the Big Bang is really the beginning of the universe, that 14 billion years ago there was a creation ex nihilo, that the universe was brought into existence, all space, time, matter, and energy. The first evidence for this was observed by a scientist named Edwin Hubble. He noticed that the universe was expanding, like this is a picture of raisin bread, and as the raisin bread expands, all the raisins get farther apart. And this is what's happening in the universe. Not really raisins, it's an analogy. The galaxies of the universe are moving farther apart, which means it's expanding. And if it's expanding now, it must have started to expand. Scientists realized that if the universe is expanding, it must have started to expand, and that looks a lot like it had an origin. Scientists didn't like that. I know to some Christians, the Big Bang is a dirty word. It's also a dirty word to scientists. Arthur Eddington wrote, "Philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole." So despite the fact that this is a repugnant theory to scientists, all scientists now accept it because the evidence is overwhelming. It's so overwhelming that scientists changed their mind and accepted a repugnant beginning of the universe because the evidence is overwhelming. The evidence comes in three pieces. The universe is expanding, so it must have started to expand. We can predict how much hydrogen and helium should be in the universe. That is what was created in the first 3 minutes after the Big Bang, hydrogen and helium. And we can also measure the temperature of the universe. The universe started out really, really hot, and everything we know was compressed into a small space, so the energy was very dense. And although the universe has expanded and cooled since that time, we should see the leftover heat from the origin of the universe. It's as if you went home and turned your oven on and got it really, really hot, and turned the oven off and opened the door and let the heat dissipate throughout the room. And gradually the whole house would be a little warmer because the oven was at once very hot. So if the universe started out very hot, we should see this leftover heat. It was discovered actually by accident in 1964. It's called the cosmic microwave background radiation. And we now measure it. This picture is a picture taken from a Planck satellite, which measured the heat of the universe. And those slightly different colors are slight variations in the temperature throughout the whole universe of 1 part in 100,000. The theory agrees with what we observed to 1 part in 10,000. That's really remarkable. It's this kind of precise understanding of the origin of the universe that have caused scientists to accept it. Not only do the observations show the universe had a beginning, but so do theoretical calculations. Einstein developed the general theory of relativity in 1915, and it said the universe should be expanding. He could have predicted the expansion before Hubble discovered it, but he didn't. He actually changed his equations because he didn't like the fact that it was expanding. In 1973, Stephen Hawking, George Ellis, and Roger Penrose expanded Einstein's theory, and they showed that he actually predicted that space and time itself had a beginning. Now, I don't know what it means for time to have a beginning. I'm pretty, confined to time. Ken and I were talking about we're getting older. We're both, some have seen a few decades, more than 3 in our lives, right? And time keeps passing on, but science now said that time actually has a beginning. And then in 2003, three theoretical physicists, Borde, Guth, and Vilenkin, BGV, came up with a theory that said any universe like ours that's expanding must have had a beginning. So what we know is that both observations and theoretical calculations say the universe seemed to have a beginning of space, time, matter, and energy. And if you're an atheist, that presents a problem. Because if the universe had an origin, if everything in this universe came into existence, then whatever started the universe can't be a part of the universe. It rules out pantheism, that worldview. If the universe had a beginning, then whatever started has to be transcendent, outside of this universe. Now, this is not just a theistic idea. Robert Jastrow is an agnostic scientist, and when the evidence for the Big Bang became so overwhelming, he said this great quote, "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the rock, he's greeted by a band of theologians who've been sitting there for centuries," right? That should go over well at a seminary, right? You predicted what the scientists should see long ago. So the origin of the universe points to a transcendent cause. If you were God and wanted to show his creation, his creatures that he created, that he exists, that he's big, that he's powerful, that he's transcendent, the best thing you could do, maybe other than a resurrection, is to make the universe understandable and make the origin of the universe understandable, pointing to a necessary transcendent cause. It's, to me, the most powerful evidence for God apart from the resurrection. But that's not the only evidence for God. The next thing I want to talk about is the design in the universe, where we see God's eternal power and divine nature, just as Romans says we should. Now, this sometimes goes under the name the Anthropic Principle, from the Greek. You guys should know Greek, right? Which means humanity or something. I don't know Greek, except I don't know all the Greek letters because we use them all the time. Nevertheless, the Anthropic Principle says that the universe appears to be designed, that there are maybe 100 parameters that are finely tuned to make a universe like ours. It's as if you have a control panel with 100 knobs, and if I turn any one of those knobs just a little bit to the right or a little bit to the left, I either have no universe at all or a universe that's inhospitable to life. And each of those knobs seems to be finely tuned, balanced on a razor's edge to allow a universe like ours. Since I have all morning, I'm going to go through all 100 parameters. You knew it was a joke. I have to tell my students when I make a joke. That was a joke. But this will be on the test, all right? The first thing I want to talk about is the strength of the strong nuclear force. This is what I study in my research. This is a review for the quiz. Everything's made of atoms. Atoms are made of nuclei. Nuclei are made of neutrons and protons. Neutrons and protons are made of quarks. And it's the strong nuclear force that holds the quarks together in the neutron and proton and ultimately holds the nucleus. If you took science in high school or college, you've seen a periodic table. It's the strength of the strong force that gives us the periodic table. If I was to take the strong nuclear force and turn the knob that controls it and make it 2% stronger, I would eliminate hydrogen from the periodic table. That's really bad. Water is H2O. There'd be no water. Our sun burns hydrogen for its fuel. There'd be no stars like our sun. So if I take the knob that controls the strong nuclear force and make it just 2% stronger, I don't have hydrogen. If I take that same knob and make it 5% weaker, then the periodic table is only hydrogen. It makes chemistry class really easy. You got a periodic table, just hydrogen sitting up there, okay? But not good for life. Another parameter that's finely tuned is the amount of matter in the universe. So as the universe starts to expand shortly after the Big Bang, if there's too little matter in the universe, everything expands really quick, and there's no time to form galaxies and stars. If there's too much matter in the universe, as the universe expands, the gravity from all this matter attracts it back together, and it collapses before you have time to form stars and galaxies. If you change the amount of matter by 1 part in 10 to the 60th power shortly after the Big Bang, within the first second, we wouldn't exist at all. It's a remarkably fine-tuned amount. Now, once I gave a talk at Stanford on scientific evidence for God, and a friend of mine who's actually a physicist came up and he said, you can't use the amount of matter as one of these fine-tuned knobs. And I said, why not? He said, because we think we understand how the universe created this exact amount of matter we need. It's something called cosmic inflation. And it's a period in the early part of the universe when the universe expanded in such a way that it forced the matter to be what it should. And this got me thinking, if you have a mechanism that is finely tuned to perform a specific task, to do exactly what it's supposed to do, to turn on when it needs to turn on and turn off when it needs to turn off, is the fact that that mechanism works so well, does that remove fine-tuning at all? No, it simply pushes fine-tuning back. How did that mechanism come about? And why did it work so well? And why did it turn on when it was supposed to and turn off when it doesn't? So I think, if you study Scripture, how God works in nature, he does do miracles, but the primary way God works in nature is through the natural world. Psalm 19:1 says, the heavens declare the glory of God. The skies show the work of his hands. Read the next verses. How do the heavens declare his glory? The sun rises and sets. It gives light to everyone. It knows where to go at night. It's that the universe works. That's how God's glory is declared. God says he feeds the lions. It's an active tense. He clothes the lilies. He makes wine. I tell my Southern Baptist friends that. God makes wine, okay? So how does God work? By mechanisms. Sure, he steps in and does miracles, but the primary way we see God in the Bible and nature is the fact that it works so well. All right? So here's some evidence for God from design. I've only mentioned two. There are 100 such things. You can ask me about them afterwards. What do scientists say? Remarkable statements like this. Such properties seem to run through the fabric of the natural world like a happy thread of coincidences. But there are so many odd coincidences essential to life that some explanation seems required to account for them. This is an atheist scientist writing this. There are so many odd coincidences essential to life that some explanation is required to account for them. This fine-tuning that I talk about, you'll sometimes read, if you read apologetics material, particularly if you read the attacks against Christian apologetics by atheists, you'll have them say, well, the fine-tuning isn't real. It's something derived by humans. The universe really isn't fine-tuned. So I love this quote by two Australian astrophysicists who have done a lot of work on this. They say this reaction against fine-tuning might stem from the belief that fine-tuning is the invention of a bunch of religious believers who hijack physics to their own ends. This is not the case. The field began in physics journals and remains with physicists. They go on to write, while there is much work to be done, physics has tended to consolidate our understanding of fine-tuning. So the universe seems to have an origin that points to a transcendent creator. The universe seems to be finely tuned to allow life to exist. That points to a designer, an intelligent being. And finally, I want to talk a little bit about something called the rare earth. The rare earth hypothesis is the idea, or answers the question, what does it take in order to have a planet that is capable of supporting higher life forms? Now, by higher life forms, I mean anything more complex than bacteria. Bacteria can thrive everywhere, but anything more complex, it's very difficult. Now, if you watch Star Trek, you know that there's higher life forms everywhere, or Star Wars, or whichever one you're a fan of. Or if you read the newspapers, you might think there are a lot of planets like the Earth. But when a scientist says they've discovered an Earth-like planet, they mean one of three things. Either the planet is about the same size as Earth, well, Venus is the same size as Earth, or the planet might have liquid water on it because of where its orbit is. Well, Mars might have liquid water on it. Or that the planet is rocky and not gaseous. Well, Mercury's rocky. So when you read they've discovered an Earth-like planet, don't believe it. It's not really an Earth-like planet. It's one of those three things. So what does it really take to make a planet that can support higher life forms? Well, the first thing is you have to be in the right kind of galaxy. This is a picture of what our Milky Way galaxy would look like if we could get very far from it. At the very center is inhospitable to life because there's too much radiation. At the very edges, you can't have life either because there's not enough carbon and oxygen and other heavy elements. And right in that region between the two circles is called the Galactic Habitable Zone, and our sun sits right in the right place to have a planet like the Earth that can support life. The sun is amazing. It has so many properties that make it suitable for a planet like ours. It's a class G star. It's one of the few stars that burn long enough and stably enough to have a planet like the Earth. The Earth itself has so many factors that make it just right, from the size to the rate at which it rotates to its angular tilt to the amount of water. I spent most of my life in California, and we now know that without tectonic activity, life like us is impossible. So next time you see an earthquake and you say, why would God allow such things? That's the wrong question. Without tectonic activity that causes earthquakes, we would not be here, because tectonic activity is one of the crucial elements that's required to keep the planet having a liquid water ocean, basically. And without that, we wouldn't be here. Earthquakes are required for our existence. Our single large moon plays a role. It stabilizes the tilt of the Earth. The planet Jupiter plays an important role in our existence. Two University of Washington scientists say this about the planet Earth, which they call the Garden of Eden. If some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, that power would face a formidable task, right? If some godlike being tried to do it, it'd be pretty formidable. It is unlikely that Earth could ever be truly duplicated. There's this physicist or an astrophysicist at the University of Oklahoma who does research on how our solar system formed. And it's remarkable. It really takes a finely tuned set of circumstances to create a solar system like ours. We've discovered many solar systems, none are like ours. And I was talking to him about all these things that had to happen to get Jupiter in the right orbit and the Earth in the right orbit. And I said, as a theist, it's amazing to me. And he said, as a scientist, it's amazing to me. Right? It is amazing. Now, people think there are lots of planets, so maybe one of them should be like the Earth. In fact, you hear this all the time. We've discovered almost 4,000 planets outside of our solar system. But if you start to do what scientists call back-of-the-envelope calculation, this is the only numbers I have, so if you're math phobic, you can shut down for a minute, all right? But you can do what we call a guess, an educated guess, a back-of-the-envelope calculation as to what's the probability of finding a planet like the Earth. You have to be in a spiral galaxy. About 10% of the galaxies are spiral. The star has to be the right distance from the center. That's a 20% probability. The last one there is tectonic activity. We don't know which planets have tectonic activity. We know none do in our solar system, so we give it a 5% probability. You make a guess. This is a partial list of the things that we know are required to make a planet like the Earth. This is a more complete list, all right? When this list was compiled, there were 322 things. The list has grown, and I don't have the fortitude to remake the list, so I keep the 322 things. And if you like statistics and you want to do the math, the probability of finding all these things together is 1 part in 10 to the 304th. There's at least a trillion planets in the visible universe, so the probability of finding a planet like the Earth by chance is 1 part in 10 to the 281. In physics, we have an official terminology for a number that small. Ain't gonna happen. That's the official term. Okay? So this planet really looks unique. It's as if a creator cared about the beings on the planet, because if you do the numbers, we probably shouldn't be here. Scientists again write things like this: a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question, that there are no blind forces we're speaking about in nature. So I want to ask a deeper, maybe more philosophical question, and I still want to answer it as a scientist first. What if the universe is designed? Paul Davies, as an agnostic scientist, he may have become a theist recently because he studies this stuff so much. And he wrote this: if physics is the product of design, the universe must have a purpose. And get this, as a scientist, the evidence of modern physics suggests strongly to me that the purpose includes us. By observing the universe, which is supposed to declare God's glory, according to Psalm 19 and Romans 1, he says it appears that the universe has a purpose, and the purpose includes us. And as a Christian, I think I've heard that before somewhere. Right? David pondered the same thing for the same reason. When I consider the heavens, the work of your fingers, the moon and the stars, which you have set in place, what is man that you're mindful of him, the Son of Man that you care for him? Zephaniah was amazed of the same thing, right? God will take great delight in you. He will quiet you with his love. He'll rejoice over you, that the universe seems to have a place for humans. Alan Sandage was an atheist astrophysicist who looked at this kind of evidence and eventually became a Christian. He wrote, "It was my science that drove me to the conclusion that the world is much more complicated than science. It is only through the supernatural that I can understand the mystery of existence." So here's kind of what I've been saying. The discoveries of modern science give abundant evidence for the existence of God, but not just a deistic God, not just a God who got it going and walked away, but truly a transcendent, intelligent designer who has a purpose for humans, which are exactly the attributes described of the God of the Bible. It's as if science has come to the same conclusion as people who study the Bible about what this creator looks like. Now, since this is a seminary and I'm a scientist and an amateur theologian, I come from a family of theologians. My father was a pastor. My three brothers are theologians, missionaries, seminary professors. So I want to say a little bit about the Big Bang in the Bible. Again, if the Big Bang is God's method of creation, then it should correlate with the Bible. And this is what I think does happen. I think the Big Bang origin and the subsequent history of the universe is not just a generic theistic idea, but it actually agrees with what the biblical account says. And I don't have time to go through this. My book talks about it if you are interested. In fact, the book is written at a very non-technical level. It's not written for scientists or theologians. It's written for the average person who wants to know how science and the average person. That's really sounds. That's not what I meant, right? But it's written for someone. It's written for someone who's not technical, who wants to know how science and Christianity go together. So let me just briefly go through a few issues. First of all, you all know, since you're theologians, that the Hebrew word yom, translated day, has lots of meanings. It can mean the period of light like it is now. It can mean a 24-hour period. It can mean a long period of time. It can mean a specific point in time. It can mean annual. And I'm not a Hebrew scholar, so I like to read Hebrew scholars. Gleason Archer was one of the best Hebrew scholars of the 20th century. He translated the New American Standard Bible. He believes that if you look at the context, on the basis of internal evidence, it is this writer's conviction that Yom in Genesis 1 could not have been intended by the Hebrew author to mean a literal 24-hour day. So what does Yom mean? Well, if you look at the history of theologians, you'll find there's never a time when there's a consensus in which what the days of Genesis mean. Some people think they're 24 hours. Some people think they serve as an outline, the framework hypothesis. Some people think they're analogical days, they're God's days, they're analogous stars, but we don't know what they are. Some people think that each day is a long period of time. When I talk to theologians who are honest about this, they say, we really don't know. Here's my best guess. I personally believe in what's called the day-age view. I think each day is a long period of time. So Genesis 1:1 is the creation of the universe. In the beginning, God created the heavens and the earth. That's a Hebrew idiom for the whole universe. I think that took 9 billion years. Genesis 1:2 then gives us the perspective of the rest of the story, and I'll look at that in a second. And then I think the rest of the 6 days of creation are the 4.5 billion year history of the earth. Genesis 1:2 to me is the key verse in the whole passage. It's often overlooked. So what does it say? It says, the earth was formless and void, and darkness was over the surface of the deep, and the Spirit of God was moving over the surface of the waters. Note what it says and doesn't say. It only says darkness is on the surface of the earth. It doesn't tell you what the rest of the universe is like. It says the earth is formless and void, and it says God is on the surface of the water. I believe the story of creation, the 6 days, is told from God's perspective on the surface of the water, on the surface of the earth. And with that perspective, the story of creation of the 6 days aligns perfectly with what we've seen over the last 4.5 billion years. By the way, if I was to transport you back to the earth 4.5 billion years ago, and I wanted to describe it, it would be formless, void, dark, and watery. It's watery because the earth is almost completely water 4.5 billion years ago. There's almost no land. It's dark because the atmosphere is so thick and there's so much debris and dust in outer space that although the sun and the moon and the stars are out there, you cannot see them on the surface of the earth. It's formless because it is still, there's no land, it's still kind of forming, and it's void because there's no life. I had an astrophysicist friend who was an atheist, and he read Genesis 1:2, and he said, how could a writer some 2,400 years ago understand what the conditions were like on the primordial earth? And he said, this book, the Bible, must be special because Genesis 1:2 describes exactly what the earth was like 4.5 billion years ago. And after reading the whole Bible, having never met a Christian, he became a Christian because this verse described what the earth was like 4.5 billion years ago. It's quite remarkable. Anyway, from a perspective then on the surface of the earth, I think the story in Genesis 1 follows science. Here's the details, which I won't go through. And then if you want more details, I've written a book about it. So I'm not a millennial, as you can tell, but my millennial friends about 2 years ago said, you know, Mike, you travel the world, you talk about science, Christianity, nobody can get any information from you. So they said, you need to write a book, you need to make a blog, you need to get a YouTube channel. So I've done all that. If you're interested in this stuff, you can go to it. Thank you so much for inviting a physicist to come to your chapel. I appreciate it.